So I want to talk about what motivates students, and I don't want to talk about the ordinary thing about problems that are relevant in their lives. I want to talk about other things. So I had this idea. I asked a bunch of students what motivates them in mathematics. So these students are all engineering students who finished calculus. They, not a random sample, but they're students I love, so I asked them, why do you like mathematics? A bunch of engineering students. What do you think they said? So here's Javier thinks he enjoys math because it makes him think critically. Jessica likes solving long problems. And Michael enjoys math because it's difficult. So I think it's worth thinking right away. There may be other things on students' minds. So I'm going to break now and do a little math, if you don't mind. The problem I want to do is I want to count how many regular hexagons can be found in that figure. Okay, so we're going to do math for a little while. I'll get to the students later. So you can probably see some regular hexagons. There's one. There's one. There's. But after a while, you can't really count them because they're a mess. So I want to put a dot at the center of each hexagon to count it. And so for example, that dot there represents that hexagon. Okay, so now we're ready to count.
1, 2, 3, 4, 5, 6, 7. And then there's 3.
Yeah, you're ahead of me, aren't you? So there's 7, but there is one more. A big one. A big one. There it is. So I got 8. Now your mind may already be racing ahead. 8, that may be an interesting number. There's a lot of things about 8.
So what's the next bigger one?
So let's do another example. Okay? Going to be more hexagons you're expecting, right? Okay, so let's count some little ones.
1, 2, 3, 4, 5, 6, 7. 19.
Yeah. Trust me, there's 19. And there's some middle-sized ones.
There are 7 of those, must be 7.
Yeah, you're thinking 7 again. There were 7 of those. How many more? 1 more. So we got, think about this, 19 and 7 and 1, 27. 8 and 27. So what is significant about 8 and 27, do you think? Perfect cubes. 8 is 2 cubed. And 27 is, I'm catching up with my slide. 27 is 3 cubed. So I want to pause now for a minute and sort of ask you to examine. Well, let's go one more. So instead of doing one more big number to see if this cubic thing, well, let's do it with a small one. That's always the easy. The inner mathematician tells you to do the easy stuff first. 1 is 1 cubed, right? Okay, so we're good with the cubic conjecture. Okay. But I wanted you to pause right now and say, what is it about you, your relationship with mathematics, your personal relationship, that makes you believe that this pattern probably goes on and that there's probably a darn good explanation for it? There's something about you and your relationship to math. A couple more quotations from my students. So do you look at math with the same kind of wonder that these students are? Okay. So before we go on, I wanted to give you a chance to just stare at this. What is it about these patterns of dots that makes these come out to be perfect cubes? Stare at that. What makes those come out to be perfect cubes? Okay, hold on. Here we go. Why is that a perfect cube? Okay. So how cool was that? Isaiah says, math makes me feel like I'm seeing really powerful basic properties of the universe at work, which just feels cool. Can we do it with this? Can you see the cube? Can you see it? So what I want you to think about is, why do you love math so much? Doesn't some of it have to do with that sense of wonderment that you get when you're doing math, when you see things like this? And shouldn't we be looking for ways to give that to our students? Now, St. Thomas Aquinas was not a student of mine, but I think he's right. And I think that wonderment is the desired state for students, and that wonderment is the supreme motivator for students. And that's it.